Okay, then we can start. First of all, thank you very much for joining this this session tonight at 6 p.m. I know that for European guys it's quite easy to handle, but maybe from US or from Asia it would be a little bit late or a little bit early. However, we can start now. We would like to talk about user-defined function, with what has changed when it came first in SQL 2000 up to the current version of SQL Server 2019. The web link for this is the following. I'm using a database, a demo database called Customer Orders DB. You can download it from here. As long as I'm in business, you can download this database if you want. The slide deck and scripts will be provided after the next session when I see some improvements for it, because you need to know this is the first time that I'm demonstrating this session. Okay, this is me. My name is Uwe Ricken. I'm from Germany, and forget about all the commercials on the left side. For you, more important is my email address. So whenever you have a question concerning SQL Server Engine, then do not hesitate and send me an email. I would really appreciate to get emails from you with questions about SQL Server, and maybe I can help you with it. Okay, then let's start. We are going through these 5 topics. What is a user-defined function in SQL Server, which has been implemented since 2000? What are the limitations of user-defined functions? What types of user-defined functions we have? And what problems are occurring with user-defined function? And you will see that we get a lot of them. And after we know the basics about the user-defined functions, we go to the improvements, the optimization and improvements of user-defined functions, which came first in 2014, and the big improvements came with 2017 and 2019. And we go into details about it. You know, this is the SQL Server interest group for the engine. I promise you we'll go a little bit deeper into the topics. Okay, so what are user-defined functions? User-defined functions are available since Microsoft SQL Server 2000, and you can use them like any other function in any other program languages. So a user-defined functions will cover routines which accept parameters, for example. And the good thing for all this is what heavily is used for. User-defined functions are mostly used by developers because of the reusability of their code. Maybe you know a situation where you say, come on, I always need to have the calculation of, for example, of a customer rating. And if this rating is a very complex function, then you don't want to put it every single time in any SQL statement. So you cover it in a user-defined function, and then you reuse this user-defined function. The very, very good thing with user-defined functions is if your rules are changing, let's say the definition, when is a customer an A, B, or C customer, you don't have to go through all your codes in your queries, in your views, store procedures, but you can only change these user-defined functions, and the new rating will be immediately available for every query where you use this function. So that was the main intention when SQL Server came in SQL 2000 with the first time with user-defined functions. And me, at that time, I was a developer at that time. I used it heavily because I loved this. I came from a procedural coding like Visual Basic, for example, and I was using lots of functions in it because for the reason of reusability of code. So I used it quite heavily in SQL Server 2000, and here comes the bad point. I was only testing with a few data, let's say 1,000 rows, and it was working like a charm, and I said to myself, yay, what a great thing, I want to use more of them. But then we came into reality and we used these functions, for example, for a calculation with 1 million rows. Yeah, and then the problems occurred and we had to roll back everything what we have created with user-defined functions. So that you will not trap into this pitfall, that's the reason why I do this session here for you. User-defined functions allow modular programming. Really one of the biggest benefits you could ever have. User-defined functions can be modified independently of the program source code. They can allow faster execution. You see that the can is bold because mostly when I see implemented user-defined function, they are quite bad at developed. And the problem is that the developers are thinking of row-based execution instead of set-based. That is one of the biggest mistakes. T-SQL user-defined functions reduce the compilation cost of T-SQL code by caching the plans. Scalar functions are completely off here, but they could really give a significant performance advantage over T-SQL's functions for calculation of tasks, string manipulation, business logic, all this kind of stuff. So whenever you want to use Scalar functions, I would prefer Scalar functions if I would have the skills to do this. T-SQL functions are better suited for data access intensive logic. That's what I want to show you. User-defined functions can reduce network traffic. An operation that filters data based on some complex constraints that cannot be expressed in a single Scala expression, that can be way better expressed in a function. But therefore, there are a few things what you need to consider when you're dealing with that. So yeah, you all know Microsoft, and wherever comes a very cool thing into Microsoft SQL Server, then you always will have a few limitations and restrictions. I think everybody of you knows that. Think about cluster column store indexes or column store indexes, that everything has limitations. So for functions, we cannot perform action that modify the database state. I think that's quite easy and understandable. We cannot contain any output into clause that has a table as a target. That does not work. We cannot return multiple result sets. Same problem here, because lots of developers want to have more, but that's not feasible with user-defined functions. We do not support try catch error or raise error as an output. We cannot call store procedures from inside the store procedure, but what we can do, and that is a cool thing, we can call an extended store procedure. That will work. Yeah, one of the, for God's sake, good thing is that we cannot make use of dynamic SQL or temporary tables. That does not work. If you need to have tables inside a function, then you need to use table variables. Set statements are not allowed, and the for XML is not allowed too. We have two types of user-defined functions. First is a Scalar function. That's what we take care of the first time. User-defined Scalar functions return just only a single data value of the type, of the data type, which you define in the return clause. It's like a normal function as you do see it in VBA or in any other program language. For an inline Scalar function, the returned Scalar value is the result of a single statement. We come later on when we to this topic when we're talking about table valued function. For a multi-statement Scalar function, the function body can contain a series of T-SQL statements, but as you know, it is only allowed to return just only one single value. Text and text image, blah, 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 is not allowed. And then we have the table valued function. I see more often table valued functions than I see Scalar functions. User-defined table valued functions return a table data type. And we come later on to inline table, what the difference between inline and multi-line. For an inline table valued function, there is no function body. The table is the result set of a single select statement. So an inline table valued function can only contain just one single select statement. So then we had a paradigm shift with SQL Server 2017. That means in SQL Server 2016 and prior, after the workload was that after the execution plan is created, it is used in consecutive query executions without changes. And that is one of the biggest problems. With 2017, with the adaptive query processing, that was definitely a new area of query execution. That means that SQL Server was splitting the query into two different parts. The one part was the table valued function or the function itself. And on the other hand, we had the SQL statement, the basic SQL statement, which was then get together with the result of the function. And so we had a way better understanding of the returned number of rows, the estimated number of rows, and especially Scalar functions performed way better. I will demonstrate it later on. With SQL Server 2019, intelligent query processing was coming into the game, and that was a great benefit for Scala user-defined functions. We now have the possibility to use inlining, automatic inlining for Scala functions. I will show you what I mean with this. Basic Scala functions are very simple. A Scala function returns, as I said, a single value every single time it is invoked. And it can be used in a select statement, can be called from applications to get one value back, can be used in functions, store procedures. And the good thing here is that you can use it as a check validation, so as a check constraint. If you create your table, and then if you want to have dedicated values for a column, then you can create the business rule with a Scala function and put it as a default into your table or as a check constraint. Scala functions cannot do complicated math or retrieve values from a select statement. What does this mean? When you have Scala functions, so they can do complicated math. So whatever you want to do, put it in your function. You can use if then else constructs, you can use select statements, whatever you want to get to a value. You see it here in my example on the right side. A Scala function is very simple to create. The first thing is that you have to define the parameters for the function. So you see here that I have the customer ID and the order year. And after this, you define the data type for the return value. So return int does mean that we go that the return value will be an integer. And then you put your code into a begin and an end block. That is a mandatory requirement. So whenever you create your function, there's only one function type that is where it is not allowed. Whenever you start with that, you start with a begin and you finish with an end part. And in between, that is the code which covers your math in between the Scala function. You will finish with a return. That is a must do. So whenever you want to finish your function, you have to mention it by a return and then a return value. The return value must be the same data type as your defined return value. If not, then it could be that the function will fail, or it will try to convert it to the data type what you defined as an output parameter. We have some problems with Scala functions. Oh, not a few. We have lots of problems with Scala functions. First thing is, when you're using Scala functions, you can use it in all parts of your query. For example, in the output part. So when you put it into as an output, as a column in your output list, then it does mean that you only say select all your columns, and then you say function as output column name. And this could lead to a problem with CPU and I/O consumption. I will show it later on. So that is the thing what I mostly see, that people are creating Scala functions because they want to have it as an output in a view or in a store procedure or in any SQL select statement. And then they are wondering that suddenly when they run this query, the CPU is at 100%. And the reason for that is very simple. When you run a select statement with a Scalar function as an output, that means that this function will be invoked for every single row. That was the hard way I had to learn too when I was a developer back in 2000. Another big problem of Scala functions, same as with multi-line functions, is functions cannot create execution plans which go in parallel. What means that, let's say you have a select statement over big tables, and whenever you need a Scalar function in it, SQL Server will always run the plan with just only one thread. And that could cause some trouble. That's the reason why you should try to avoid Scalar functions in a select statement. Here are the points. Iterative invocation, that's what I said. So whenever you have Scalar functions in the output, that means that every single time a new row gets retrieved, it has to call this user-defined functions. Another big problem is the so-called lack of costing. The people who are experienced with execution plans know that there is sometimes in your execution plans an operator called compute scalar. The problem with this compute scalar is that the costs for this operator is always nearby zero. The reason for that is quite simple. Microsoft was never expecting that a internal function will be of high costs. So that's a problem, that these Scalar operators will not always, not at any time, represent the real costs of your function. Interpreted execution. UDFs are evaluated as a batch of statements, executed statement by statement. Each statement itself is compiled, and then the compiled plan is cached. And what I said, the serial execution, we are not allowed to run a parallel plan. But 2019 brought a big improvement. It's called automatic inlining. Long story short, automatic inlining does mean that SQL Server will try to make the Scalar function a T-SQL expression. So, and that is one of the really cool things, what I want to demonstrate to you now. And therefore, I need to switch over to another desktop. Sorry, let me just, here we go. And we go to this one. So I hope that you can see this. I have my database finished so far. And what I do now is we go with basic Scalar functions. I hope everybody can see this here. So what I want to do is, the first thing I will make sure that the behavior is for Scalar functions like in 2000 and earlier. So and later, but here we do it like this. Okay, so let's go. So we are now in a SQL Server 2014 level, and what I'm doing is, first of all, I try to get some data, my customer data and my customer orders. Takes a little bit, but it's okay. And then that comes later on. Here is a basic query. You see here, I want to have the name of a of the customer, and what I want to have is the number of orders per year. Very simple. I don't have any index here. The reason for that is I want to show you the problem with parallel plans. Let's run this query just only for one single record. And here we go. We get just only for one customer the orders per year for 2019. And we want to go to the execution plan. And here you see what the execution plan is doing. It is absolutely okay because we don't have any indexes. So see what happened here. We're doing a full scan on the customer orders, which gets back with 3 million rows, but only 10 of them are affected. And then we go with the customers and we go in a nested loop, looking for every single customer. So that's so far okay. And you see that SQL Server is using a parallel plan. So now a developer comes and say, well, what I want to do is these orders per year, I use it everywhere in my application. So let's create a function. And this function, I only hand over the customer ID and the year, and then it should return the number of orders for that year. Here is the query. It looks very simple, but it is a Scalar function. The Scalar function does mean it's defined by. We have just only one return data type, and we finish it with return of the return value. That's it so far. And we skip this here, then we go to this here. Now this fun begins. You see here that I run a query which say, please give me for customer number 10, the number of orders for 2019 as orders per year. It is from the result, exactly the same query. Let it run. Wow, incredible fast. And when you look to the execution plan, I bet you will say, wow, that is incredible cool. Because SQL Server tells you, well, I only go to the customers, then I do a little bit of black box computing, come back with a result, and here is my result. 2 points are mandatory here. First thing is, also we are using a Scalar function. It is not been here in the plan directly visible. The only thing where I can see it is here in the compute Scalar operation. And what you see here is that we are using our function orders per customer and year. That's so far okay. Please have a look to the costs. SQL Server is telling us that the cost is just only 2% estimated cost. So most of the time is consumed by the table scan. And when we go to the I/O, that looks absolutely weird. Look to this. The customer orders is scanned, and with SQL Server is telling me, well, okay, it's only a few IOs. We have 683 IOs. That's all. And that's everything what we need to do. Look to the CPU time. It's 700 milliseconds. It took half a second for just only one row. So when I don't look, excuse me, when I don't look to the execution plan or to the I/O, my first feeling would be, wow, this is incredible fast. But let's go again to this one here. Again, with the number 10, just only one row, go for it. It seems to be that it is more expensive, but have a look to the CPU time and elapsed time. The CPU time is a little bit smaller. Yeah, the reason for that is that we don't use a function. We don't have to call a function. And we compare both together. Look to this. And that looks absolutely weird. The first one, the second one. When I look to the execution plans, and let's say you're an unexperienced developer, which means not unexperienced for development, but unexperienced with execution plans, what would be your choice? When I see that this query just only consumes 1% of the total running costs, and the other one is 99%, then I would definitely say, oh, come on, my function is so cool. It has downgraded the costs by 98%. Absolutely super cool. But it isn't. SQL Server is calculating the costs under I/O. And when you look to this, you see this is the first one, which say, come on, 683. And why the other is so expensive is just only because of the logical I/O for the customer orders. Because it's 70,000 more IOs visible. And SQL Server think, well, okay, come on, 70,000 IOs, that makes the 98% of the difference. So, and that is a little bit misleading here. So that seems to be absolutely perfect. However, if you deal with a function or with the second candidate where you have the cross apply in it, which is nearby the same, but the system starts definitely to decrease when you do this with more rows. Here you see what I mean. What I'm doing here is I set statistics IO time on, how long does it take? And then I run this query for 100 rows. I wait 5 seconds and I run this query for 100 rows. In the meantime, what I'm doing is that I will show you the perf one. Can you see it? Hopefully, Frank, can you see the CPU? My CPU
no.
window?
No.
Okay. Yeah, then I do it another way, no problem. So what I'm doing then is, let's run this query, statistics, IO, and time on. I let run this query here, and it never comes back. It's just only 100 rows. The problem here is that SQL Server is now calling the function for every row in the row set of 100 rows, and have a look to the CPU costs. I see it takes a while. I know, no, my machine is currently running. I think it's a problem of Teams here. However, let's wait a few seconds. It should finish now. However, in the meantime, I take this query. I run this here in another window. So let's run this. Done. We took less than 2 seconds, and this one is finished now. And when you have a look to it, here are my 100 rows. And please have a look to the execution time. So it took 37 seconds to execute the query, but see what CPU times we have consumed. So pure CPU time, and I feel it here because it's getting hot here at my computer, because my CPU is up by 100% now. And when you look to this one, then you see, oops, then you see that, one again, here we are. When you look to the messages, look to this. My CPU time doesn't went up. Also, we are taking 100 rows. The point here is that SQL Server was taking the row or the set-based approach, which means give me all the customer orders. This is one single step, and then merge it with the customers. My other function here did it in a completely different way. What this function was doing, give me row number 1, then run the customer ID with the year 2019, get the output, and then push the data out to the select statement. And this has been done 100 times. So we have 100 times calling the same procedure. And this is something what is what makes it really, really expensive. So why is this so expensive? The reason is that whenever SQL Server invokes the Scalar function, SQL Server has to evaluate and run the query again and again and again. So what I'm doing now here is I want to create an X event, which tracks for me whenever SQL Server will start a statement and then it will stop or complete a statement. So this is my X event. So you see that the dispatch latency is just only 5 seconds, which means that we get faster results. So here in my management, oh, my CPU is running. I see here my extended events. And in the extended events, I have my track Scalar function. I start this. So I don't have any source where I will save, my target where I will save it. I just look live data. That's enough for me. So then we can close this window. I run this query again. Here is my event, my session with the ID equal 10, and let's see what's going on now. Yep. So here we are. And now you see what SQL Server is doing, and that is really important to understand. You see here that we have the statement running first. It was the SQL statement starting. And please have a look to the statement itself, what SQL Server is doing. SQL Server is calling my query, so my select statement. In that moment, we do not know anything about the possible output of my Scalar functions? No idea. Then what we see is when the query is starting, and the first time we just only have one row, keep that in mind, the number customer number 10. Then we start invoking the function, and here you can see that here's my count back. That is inside my function, and then when it's finished, look to the duration of how much time it took. It was 352 milliseconds. So the mandatory part of the execution time was coming from my function, not from the major call of my select statement. So my function was consuming all of the CPU time. And that is something what makes it a little bit difficult here. So when I do this with this one here, you see here that I'm now using my function as a predicate. So I say, please give me every single customer with an ID smaller than 100, and please check that they have more than 5 orders in 2019. I will delete the data, run this, and I think that most of you know that we have here a non-searchable query. So what does this mean? We go through all the customers with the ID smaller or equal to 100, and then we run the query again, or we run the function here. So in the meantime, we should have some data here, and you see what's happening. Here starts my, we're only at 40, so 40 rows. We have 62. That means we have 30 rows, and so on. And look what happens here. SQL Server is starting the, yeah, takes a while. SQL Server is starting the query, and then it calls again and again and again, calls the function. So, and that makes it so incredibly expensive. So we are finished. It took 34 seconds, and now you can clearly see where all my time is gone. My time was gone by the duration for every single invocation of the function. So you see that SQL Server was running it 100 times. You see 202 events. You see that we have a starting and completed. So that means that every single call has 2 separate lines, and there we have 100 calls of the function. And that made it so incredibly expensive. Here again is my CPU time, and here is my elapsed time. So that is definitely a big problem what comes with Scalar functions. The biggest mistake here is that people are completely thinking about, well, I'm using a reusable code, and when they test it just only with just a small row set, and when they think, well, yeah, that is okay, that's fine, and that's fast, then they implement it, and when they come to the real life data with millions of data, then it doesn't work. So that was something where Microsoft was thinking of, and they improved it in a perfect, really perfect way. In SQL Server 2019, we have so-called automatic inlining. The automatic inlining, I will switch over again to the presentation. Please hold on. Here we are. Automatic inlining does mean that SQL Server tries to transform UDFs into a Scalar expression or a Scalar subquery. They are substituting the calling query in place of the UDF operator. That is a really cool thing. That means that the query plan will not have any user-defined function operator, compute Scalar, but it will better be affected by using set-based operations, and that is the improvement. Here you see my query. You know that I don't have any indexes here, but there are 2 major problems or major improvements. First, before SQL Server 2019, you see that SQL Server only shows me the table scan, the filtering, and then it comes back with the compute Scalar, which is my Scalar function, and then we do the output. So far, Does mean that we consume lots of CPU time. You see it here, it takes 639 milliseconds in this example. In SQL 29, you see just a little part of the execution plan, but there are two major differences. First is, have a look to the operators. They all do parallelize. That means that we can use more CPUs if required. That is one big improvement. That's something what Scalar Functions normally does not do. And the second is that we now have a regular execution plan, which seems to be like a typical join operation. For example, that we have the table scan on the one hand. This is what we only saw before. And now the Scalar function has been transferred to a SQL statement, which say, please give me from the DBO customers all the 3 million rows, run a filter about it, aggregate them, and push them or merge them with the table scan operator. With 2019, you see here not only the customers table anymore, you now see that the customer orders gets accessed in the same way. And the second thing, what is pretty cool, a third thing, what is pretty cool, have a look to the execution time. The execution time looks way better here because when you deal with more rows, then it's way better than it was before. Sometimes it could be that the performance will be a little bit slower, but think about the following situation. The benefits of these Scalar function improvements do not come when you just only run the query with a Scalar function just only against one row. The benefits will come if you're dealing with larger row sets. And that's something I want to show to you in the next demo. And therefore, I have to switch again back to my SQL Server Management Studio. Oh, come on. Takes a little bit. That's something I don't like at Teams. So the only thing what you need to do is go and set the compatibility level of your database to 2019. I then run the query. It's exactly the same. I don't change anything here. The only thing here is my original query. I'm running for number 1000. Look to this, it was quite fast. Let me show you the execution plan. We go in parallel. We see that we scan the customer orders and the table scan on the customers. We come back with a nested loop. So far, okay. And when you remember, when we had the function, then we had the problem that it was executed lots of times. Here we go again. This is the only thing what we need to do. We change nothing in our function. We don't change anything in our application. We run exactly the same query again, and when you have a look to the execution plan, just a second. Is it the right thing? Yes. I need to check it. One moment. Yeah, it's okay. We did this. So what I want to do is I create an X event. You saw the former work, how it was working. And what I want to do now is, let me check this out. I create an X event. And then, come on. This is my statement here. And this one should now work with Ouch. One moment. Gut ist, du kannst alles rausschneiden. So let me check. CPU time is smaller than 1000. This is the first time I'm doing this. Let me check this again. I'm wondering that it's not working, and this is something what makes me a little bit curious. Did I change it? 150. We are here. We should have our function, which is inlining. Yes. So once again, fingers crossing everything will work. Watch the live data. And here is my function. That makes me, so I have to check why it's not working. This is something that makes me a little bit confusing. Let me check this out. Maybe my alter database is scoped configuration set. One moment, I have to look for it. It is let me check this. Just hold on, just only a few seconds. I don't know whether it's activated or not. Just database code configuration. I think TVF. Yeah, here it is. Sorry. Let me. Ist gleich. So after 5-minute breaks for a beer, it should work now. So we are on 150. We have the inlining activated. So once again, we run the query, and now finger crossing. This is the original one. This is my function. And it's not working. This is really weird. This is really weird. Let me check this. Execute. It's there. Ah, okay. It's working. Don't know what happens here. Just a second. So clear data. And now see when I run this query, what happens. And that is a really interesting thing. So here we come with a Scalar function. And you see that the Scalar function is running my query as a very perfect plan here so far, because it's running in parallel. It's more information than only the table scan. And if you look to the data, it should have done it. This sucks. Yeah, okay. So what you see here is that there is no call of the function anymore. The reason for that is that SQL Server will now try to put the function into a T-SQL statement and use it as a normal set-based operation. That's the reason that there is no separate function call anymore. And that's the same should be with the where clause. Let's check this here. But what you can see then is here we starting. There is no more call of a function, and SQL Server will handle it as a T-SQL statement, as a select statement. So that is a point where inline or Scala functions are way better in improvement. It can be better, but there is no real guarantee that it will be better. And let me check this once again with this function here, but go for it. So my CPU is here on 100%. Frank, I think it's coming from Teams. I don't know if it's the same with yours.
Yeah, could be. I don't know.
Okay, yeah.
Let me check.
It's cancel the query. Yes. So this is it's quite hard here. So, however, we go over to the next thing. The automatic inlining is so far okay. The basic requirements, there are a few of them. Let me show you the requirements for that. And what I want to do is, here is my thing. So 2090 broad automatic inlining, which means we have the basic requirements that it can be automatic inlining. It must have a select a statement, if then else is allowed, and there must be a return for a single or a multiple return statements. The restrictions, I think they are very clear. It is not allowed to use non-deterministic values, so the get date or intrinsic functions, use sequential ID, everything which is not stable. No reference to table variables is allowed. It could be that you have Scalar functions where you hand over as an array a table variable, but then it will not be an automatic inlining. You should not or cannot use order by. No reference to user-defined types are allowed. So I see quite often that developers are using user-defined types. I wouldn't do that but it's okay. I mean that you address the system types by your username, and no references to CTEs are allowed. Then we come with multi-statement table functions, and these kind of functions I would say mostly. Multi-statement table functions are user-defined table-valued functions which return a table or a data type. The point here is that inside this table function, you can have multiple steps, and you insert, for example, data into a table variable. And the last statement then will be that you return, that you just only quit the function by putting in a return statement. And the table variable, what you have defined, you see it here in the second line. My variable is t. I put in all my data. And when I put in my data and I finish my function with a return, the content of this table gets returned to the client. The function basics or the function setup is exactly the same as for a Scalar function. You define parameters for the function, so what you want to hand over. Then you define the structure for the table which returns from the function. So you can use a typical normal block like you do it for a create table statement. You can index them, whatever you want. You can do it with the table variable. Whatever you can do with table variables, you can do with the definition of the return table of your multi-statement table function. Then you start as with the Scalar function with a begin and with an end block. That's mandatory thing. And then you do all the activities which produces a table to be returned to the function. In my example, it's very easy. I just only say, please give me the top n rows. That's for my example, what I'm using here. But you can say, put in all my rows from a dedicated customer, then do some complicated math, some calculation, and then you put in, you return back the table variable. Every single function, multi-statement table function, need to have at the end a return statement, just only a return, nothing else. That means that we quit the function and we get back to the client. The biggest problems we always have with multi-line functions is definitely the wrong estimates. These estimates made the biggest problems ever when you're using multi-line functions. Before 2014, so that means including 2012, we had the old cardinal estimator, which comes from SQL Server 7. And whenever you were using a function, a multi-line table-valued function, the estimated number of rows was always 1. Nothing more, nothing less, always 1. With SQL 2014 and 2016, especially with 2014, there was a new cardinal estimator, which was coming into the game. And with 2014 and 2017, the estimated rows has been increased from 1 to 100. So you can think of, if you have multi-line table valued functions, which normally return more than 1,500 rows, then it could be a massive degradation of your query. And I saw lots of them. People were dealing with multi-line table valued functions for a huge amount of data. Maybe you heard sometimes or read in a blog the recommendation, a table valued function should not have more than 100 rows. The reason was coming from the limitation of the estimates in 2014 and 2016. But then the reason for that, why it is so, you see here, but I will come with this screen in a demo, because a demo is way more interesting than only seeing this PowerPoint. I go back again to my Management Studio. Okay, here we are. Close this. First of all, yes, so multi-line. Excuse me. So here we go. I go into my demo database, and what I'm doing here is a very simple thing. What I'm doing is I create a multi-line table value function where I hand over the number of rows, and I add, just only for a little bit of math that you see that we can use if then else constructs, shall I recompile the query or not? So the table returns an order ID, the order number, and the customer ID. And I say, okay, if I want to have it with a recompile, then do this. Sorry, if you don't want to recompile, do this, else do that. Very primitive. I have seen functions with hundreds of lines of codes. So here we are. It's done. So, and now I go back to SQL Server 2012. So here we are. And when I run this query, I only say, please give me 100,000 rows. I have 3 million rows in it, and sort them or order them by customer ID. I don't want to recompile them. So look to this result. Here you see we got the 100,000 rows, and have a look to the execution plan. The execution plan see lots of problems. First of all, whatever you see is that the query or the function gets invoked here, and then we call this function here, and we come back with 100,000 rows. That's fine, but you see that the sort operator is that has an informational icon here at this side, and when you go on it and you see that there is a warning. The operator used tempdb to spill data and so on. I think most of you know this warning, and that does mean that we have calculated too less memory for the operation doing in the memory. So the reason for that is here. When you look to the actual number of rows, you see, well, okay, it's 100,000, but the estimated number of rows is just 1. And then for 1 row, SQL Server say, well, okay, come on, I just only need my minimum affordable memory grant, which is 1 megabyte. But for 100,000 rows, it is way too less. And that is the reason why the sort spills into tempdb. Okay, Microsoft said, or first of all, developers said, well, okay, then let's do it with a recompile, because then maybe we can sniff the value, and we do this with table variables in the same way, and it works like a charm. Let's do it with the function too. So you remember that I have the second parameter, the number 1 here, which say, please use now the option recompile. I run the query again, now with a recompile. And when you look to the execution plan, you see that we always have the same problem. The estimated number of rows is exactly 1. So it doesn't change whether you do a recompile inside the Scalar function, the table valued function, or if you do it outside in the statement itself. It won't work. A table valued function will always return 1 row. So what did developers do then in that case? They took the function and pushed all the data into a temporary table. Then they had statistics, and then they knew how many rows we had. Then we come to SQL Server 2014 and 16, where we had the brand new cardinal estimator. That's what I'm doing here. I'm now changing the compatibility level to 2016, because 2016 and 2014 have the same calculation. I run this query again with 100,000 rows. And when you look to the execution plan, you see exactly the same problem. The sort operator is again pushing out a warning, say, well, I have to spill to TempDB. And the reason for that is the estimated number of rows is just only 100. So that is the improvement made by Microsoft with the new cardinal estimator. Whether you're doing it with compile or with recompile, it doesn't work anymore. You always have to think about that we have 100 rows in it. And that is the recommendation, what you always hear when people are talking about table variables. Don't use more than 100. That's the point here, because that is the estimate. And then we come with 2017. SQL 2017, we run this query again. And here, come on, you suddenly see a completely different plan. Because what SQL Server now is doing, you see here, there is not anymore the estimate of 100. No, SQL Server is telling me, I know that we have 100,000 rows. And again, it doesn't matter whether you recompile or do not. And I want to show you how it is working. Therefore, I create an X event. One moment. I'm wondering details. Oh, here it is. So first of all, I make sure that I'm in the 150. And now, only for performance reasons, I put in clustered index on my customers. Oh, sorry. Here we go. Oh, yeah. Okay. So now I again create an X event for multi-line UDFs, and here we have it, refresh. And we want to see the live data again. Hopefully this will work. So the first thing what I'm doing is I deactivate the interleaved execution again. I clear the procedure cache. So now it does mean that SQL Server is acting like it was in 2014 or 2016. And what you see then here is I run this query. I say, please give me the customer and the name from the first 10,000 orders. I know it's a stupid query, but it helps to understand what's going on here. Here's my query and the execution plan. And you see here that SQL Server is again have the problem with the estimates. We say it's 100. So what SQL Server is using, it's using a nested loop operation because of the small amount of rows which get back. By the way, I know some DBAs, high professional DBAs, which are exactly for that reason using a table valued function that they force the use of a nested loop. That's very cool. That's their trick to use it. But let's see what in the live data what's going on. What you can see here is that forget about these first here above. That doesn't matter. So this is from the select spit. So this is dynamic SQL, and here we go. Have a look to what happens to SQL Server. That is really interesting. So this X event will trace the post compilation show plan and the post execution show plan. I stop it here, otherwise we maybe get more data. And you see here, this is the query coming from us, select star from customers, inner join, get order list. So we're starting here with our SQL statement, and then SQL Server creates the query plan. Have a look to the query plan, and you see here that SQL Server is telling me it's scanning the customer orders. Here, curiosity is that SQL Server knows that there are 10,000 rows, and it thinks, well, it's coming 10,000 rows back. these 10,000 rows are getting into this table variable here in the clustered index #t. Think about a problem from a table variable. We don't have statistics on it. So what SQL Server is doing now, SQL Server is caching it because we didn't have the information in the cache. And you see that the cache gets inserted from the get order list. Then we start with the insert into. And after we have finished, look to this, SQL Server say, well, okay, we have 10,000 rows. But SQL Server does, so the basic statement here does not know it. So we insert it, query post execution plan. Here we go. Let's have a look to it. And the post execution plan, here is my function, tells me although we know that we have 10,000, doesn't matter. A function just always is returning 100 rows. And that is coming from the SQL TFT build, because SQL Server, forget about anything what it has done before. SQL Server has a clear statement say a table valued function returns the value 100 rows. And that is a problem we have, that the SQL Server, when it's completed, say, well, okay, I was thinking that there were 100 rows just coming back. Let's go ahead and change the behavior to 2019. Well, in SQL 2019, we have the so-called interleave execution, and I run the same query again. Go back, clear the data. I don't want to have the former stuff, and execute. And now it looks a little bit more complicated, but it's very, very interesting. The very first thing what you see is that here the table variable of the table valued function is before we start our basic select statement. And that is a very cool thing. What SQL Server here is doing, it's say, okay, we go now, and first of all, we start this insert into. And when you look to the execution plan, you know, again, that we run with 10,000. Estimated numbers is 10,000. Absolutely perfect. Now we complete it at the table valued function here. We complete it. And what SQL Server afterwards is doing, that is really, really interesting. You see here, when this one has finished, the statement, so the function has finished, we run and stats update. Interleaved stats update. Look to this. The estimated was 100 and no pages, and it has changed because both are interesting for SQL Server for the estimation of costs. Now it says, well, the actual pages I have received, or which is in my table variable, is 34 pages, and we have actual cardinality 10,000. So this is the information what SQL Server now push into the cache, and then my statement is starting. So after the evaluation of the function, we start our generic SQL statement, which now knows the information about how many rows we have in. So when we go to the query post execution plan, you now see that SQL Server has changed it from a nested loop to a merged join. The reason for that is very simple. SQL Server is telling me, well, I was thinking about that we get 10,000 rows back. And another thing has changed. You see that the sort operator does not have any more warnings that they spill data into tempdb. The reason is very simple. Due to the fact that we know that we have 10,000 rows, the memory grant has changed. It's not even more 1 megabyte, it's 1.5 megabytes. It's a very small table. And that is a very, very cool feature. The only point what needs to know, what you should know is that you have the possibility, if you're in 2019, to stop the interleaved execution. For what is it good for? Well, the one point is a very, very big customer of Microsoft is permanently in contact with Microsoft when any new feature is coming into the game. And they were complaining about it. They were complaining about the changed behavior of these interleaved execution. And then Microsoft said, well, in most reasons, it is very useful to have it. So what they did is they made it a database scope configuration to activate or deactivate it. The reason I explained formally to you, it could be that developers are using table valued functions for forcing nested loops because of their wrong estimates. And because they have seen that, let's say, a nested loop is way faster than a hash join or a merge join with a sort operation, because mostly it is required that you have disk access for that. And that is the point where people were suffering from. And SQL Server now has changed it, and I want to show it again in my presentation that you can see it. It's right here. So what is the reason for the wrong estimates? Well, this is what I showed you formally. Please have a look to it that the function itself gets executed after my generic statement is starting. So at that moment when SQL Server starts my select statement, it does not have any idea about the numbers of rows which are in my table or in my table valued function. And with the interleaved execution, SQL Server does change it, because with this here, it was it's acting as follows. Before SQL Server will execute my query, my original query, it starts, if possible, if the interleaved execution is possible. What you can see here is that the interleaved execution will change the behavior dramatically. It's first trying to resolve the multi-line table valued function. Then it runs an update stats, also interleaved execution update stats, which means, hey, I now know the values, and these values, with these values, we push the information into my outer query, let's say it so, and then this query knows exactly how many rows we get back. And that makes it really incredible fast, by the way. That is really a cool thing. It could be that people don't want to have it, then they could switch it off. It's a database scope configuration. And but mostly people who are dealing with multi-line functions, and I know lots of customers who are dealing with that, they could really have better improvements. What is the drawback? There is a little drawback, because what SQL Server needs to do is it needs to recompile it every single time. So whenever you change the data, SQL Server will always, really always, first of all, recalculate the actual numbers of rows from your function, and then pushes the stats to the original statement. So that you need to keep in mind. And that is a good thing. I go back to my management studio. When I run the query with 10,000 rows, it works incredibly fast, because SQL Server knows that we have 10,000 rows. The second time when I run it just only with 10, the same behavior works. So we know that we have 10. The nested loop changes. And please have a look to this. SQL Server actually does definitely know how many rows we get back. This is a really, really great benefit we have for interleaved execution, but you pay with higher CPUs. And I go back to the presentation. You saw that I was working with extended events for interleaved execution stats. And the good thing is that you have extended events for monitoring these. We have 6 more extended events. Let me show you how I have configured it. I can skip it, it's okay. So these new extended events you can use to check whether your functions you are using can use interleaved execution. If not, then you don't see any of these events, and then you may have to rewrite the query. Last but not least, we have the inline user-defined functions. I really hope that most of you are using these kind of functions because they are the best performing functions you can use. They are restricted by a few things. You know, inline user-defined functions can only have just one simple select statement, nothing else. An inline table value function, think about it as a view with a parameter. That is an inline user-defined function. You see here in my example that I calculate the customer average per year. I know it's horrible, but it's only an example. You see that I'm counting the total number of orders for a given customer, and then I check the number of orders for the given year, and then I just only make a simple math and put it out. That's easy. Keep in mind that user-defined functions do not have a begin and end. The header is quite easy. As you say, only it returns table, not any variable. It returns table as, and then you immediately start with a return. And this return holds the SQL statement you want to push out to the client. In inline user-defined functions, no changes have been made because inline functions were performing always pretty good, because what can SQL Server do? SQL Server use an inline function and treats it like a view in a join or a cross apply. It's always the same. So it means that SQL Server will expand. It's possible to expand the content of the function and integrate it into the query strategy. Let me show you what I mean. I go back again to my management studio. Here we are. Go into my DemoDB. What I'm doing, it's only for speed up, that we don't have to wait so long. You see that I'm putting an index on the customer ID order date, and here we are. This is my function. So my function takes the variables customer ID and the year, and then what I'm doing is I'm calculating the percentage for each customer of made orders compared to the total orders for this given year. So this is my function. And what you see here is that I don't say, please return any variable. I say return table, and then I push everything out with one single return statement. Here we go. And I show you the execution plan. The interesting thing is, I hope that you know this, you can use functions in a select statement with a cross apply, which is same as an inner join, or you take an outer apply, and that is a left join. So I go here for one customer, say, please give me for just only one customer for 2019, the average or the percentage value of taken orders. So it's quite easy. We're running this. It's going incredibly fast, although we have to access the big table. But when you look to the execution plan, you can see here that SQL Server is not showing that we are running a query or with a function, but SQL Server implements the code of the function inside the whole execution plan. So it is the same as when you would run this with a single select statement without any function. So, but the good thing is here, when you run this with lots of data, it's fast as it is without or with one. As long as you have inline functions, SQL Server will always treat them as part of the query itself. It expands it, compiles it, and puts it as a part of your execution plan. So you can take as much data as you want. The good thing with inline functions is they can scale because they know the information. Here we have, you see that it's working. SQL Server is using the data automatically inside the query itself. And here I go with 10,000. I have 75,000, but it's going quite fast. It's less than a second, and you have always the percentage of the data. Here we go with 100,000. Go for it. Doesn't take very long because SQL Server is just only hitting 75,000 rows, but SQL Server is using a performant index seek for each customer. We go with it, excuse me, here with all the data. We go with a nested loop here and aggregate the information. So that makes inline functions the preferable way how you should use functions anyway. So my recommendation is whenever you want to use functions, try to avoid Scalar functions and try to avoid, especially these kind of functions, multi-line table valued functions. Also, you have way better performance in 2019. There is absolutely no guarantee that really every multi-line table valued function will perform as an interleaved execution function. If not, then it could be that you have horrible plans and that the execution takes a long time. So that's definitely my recommendation when you use functions. Use use inline functions whenever it's possible. Your challenge is if you have a complex calculation that you will think about how can you express this in a set-based type instead of a row-based type, and that makes the challenge for you. I had such a customer which was running a Scalar function, and the query took over 4 minutes. They said, okay, it is so, I take it in 4 minutes, but with an inline user functions, it was running in less than 500 milliseconds. And that makes the difference. So whenever you try it, use inline user functions. So I think, yeah, we are finished now.